Hey guys, Aaron here from Julia Guitars. In this video I'm going to show you how I build guitars on my CNC. I'm going to show you the whole process from starting in Fusion and creating the CAM toolpaths to putting the stock on the machine, machining the part, and then pulling it off and cleaning it up. Let's get started. Alright, so the first thing I do when I prepare a guitar for machining is set up my stock on my CNC. So I use these fixtures, and I showed you how to make this in the last video. If you're interested in that, I can put a link right here. And first thing I do is just put it on the machine, and I use these dowel pins to locate it. So when I machine this fixture, I drill through the holes through into the spoil board on the machine so that I can put my dowel pins on there. And I just lock it in with these little clamps. These clamps came with my CNC, but I'm sure any CNC will have some clamps that you can use. And I use the blue painter's tape and CA glue trick, so I'm just laying down some painter's tape here. Then I'll put a little bit of CA glue on after I mark the location of the tape for the body. So I'll just line it up with this little trace line, and I want to make sure my center line on my glued blank is in line with that. And I'll just locate where I need to put the tape on the blank, put some tape on there, and then I line up some beads of CA glue. And this just holds it in really tight. It doesn't move side to side, but you can pull it up really easy when it's done. Hey everybody, and welcome back to my computer. We're in Fusion 360, which is my favorite and also least favorite software because it's very expensive, but it has a lot of features which are super useful for milling these parts. Today we're going to be talking about the CAM operations, which is what the CNC uses in order to mill out a part. In this case, we're doing a base body. If you don't remember, in the last episode, we constructed this base body from a 2D sketch by extruding some things and insetting some other things. We also created a stock, which we're going to use to mill this part out of, which is basically like the raw material. And then I created this fixture, which we're going to use for two-sided milling. Notice we have these holes here, and we insert some dowel pins, then we flip the part over, and we use the same index point to tell the machine where the part is in 3D space. We have a few setups down here. Setups are basically like collections of operations that you run on your CNC. I already have two setups for the front and the back here, but I'm going to create them from scratch so you can see how I do it. So first thing I'll do is come up here to setup, and I'll create a new setup. And we don't have to select a machine. These are just kind of like sensible defaults for like the different operations you can perform on your machine, but I know what I'm doing here, so I'm not going to select it. We are going to go into the stock tab, and let's just say from solid, and we can go and select our stock, which is this stock body right here that we created earlier. And then we'll go back into setup, and we'll say our orientation is Z axis, plane, and Y axis. We will go to set our origin to a selected point, and we'll select this point down here. We will select our fixture as this body over here, which is that fixture we created earlier. And then I am going to select the model as the guitar body. I basically just want to make sure that how my axis is oriented here aligns with how my machine is set up. So for my Shapeoko machine, up and down is Z-axis, so my positive Z should be pointed up. But these are actually flipped, so my positive X would be traveling right towards 0, and my positive Y would be the back corner, because that's where the coordinate space where the origin point is back here in the corner. So I'm actually just going to flip the X-axis here, and that should do exactly what I want. So left and right is X, with positive X going right, and then forwards and back is Y, with positive Y going back. And now this should be set up correctly, so I'm just going to hit OK to create my setup. And then maybe I'll just rename this something that makes a little bit more sense. I'm just going to call this setup front. The thing I'll mention too is usually I like to start with the back operation and then flip it over and do the front. The reason why is there are less things on the back that I have to mill. And I like doing the contour from the front because I also do the pocket from the front. So it just ensures that both of those operations will line up perfectly. Because when you flip it, you might get a little bit of play in these little holes right here with the pins. So I'm actually just going to copy this, and I'll just, I guess, duplicate it. Well, let's just rename this one setup back. And then I'm going to double click into this and just make sure that I set the fixture in the origin point correctly here. So let me just disable this fixture, re-enable the back fixture. I'm going to flip it over, set the fixture to this body, and then I'm going to reset my origin point to this corner right here. And so when I do this, I'll need to make sure that I flip my Z axis so that up and down is the correct Z orientation right here with my machine. And I'll just hit OK. So now we can start creating some operations. First thing I'm going to do is bore out these holes right here. I'm going to re-enable the stock, and then I'm just going to go into 2D bore. And for my tool, I already have my full tool library here. You'll have to create your own tool library based on what you're using, but you can take a look at mine here. I have a bunch of different tools that I've just acquired over the years, but most of what I use are this first 1/4 inch upcut 2-flute end mill, which is really long. It's 3 inches long. And this works for pretty much everything. If you're going to buy just a couple end mills, I suggest this one, a long 1/8 inch end mill for drilling holes, and then maybe a 1/16 inch end mill for doing the pickup or the pick guard holes and like all the little tiny holes for mounting the hardware. So this first one, we're just going to bore it out with this 2-flute upcut 1/4 inch end mill. So I'll just select this. And then I'm going to, all these defaults should be fine if you want to take a look here. And then for my geometry, I'm just going to select these holes right here. And then I don't want to go all the way to the bottom because I don't accidentally want to gouge my fixture. So I'm just going to go into my heights, and then my bottom height, I'm just going to offset it, maybe like 0.25 or something like that. We're going to go into passes, and you can, if you want to make these holes a little bit larger so that the pins aren't super tight, you can. If you were to leave some stock, I would do negative, so it makes the hole a little bit bigger, and then maybe just like 1/1000th of an inch. You don't want too much, or else those pins will be super loose. The pins that I buy, and I'll show a clip of them here, have really tight tolerances, so they should not be loose. If you mill this exactly at the size of that pin, it should be pretty tight on there. But yeah, sometimes I'll just add a little bit of extra milling in there just so it slides in a little easier. And then everything else should be fine here, so I'm just going to hit OK. Next thing I'm going to do is do an adaptive clearing. So if I go into my 3D panel, it should be right here, adaptive clearing. And then all I have to do here is make sure the correct tool is selected. So I'm just going to make sure I select that same upcut end mill that I selected earlier, which is this one right here. Next, going to go into my passes tab right here. In this case, we can leave a little bit of stock. We don't want to machine all the way down at this point because we're going to smooth this out with another operation after. And then I'm going to set my maximum roughing step down to something that's a little bit lower. So this is half of the bit size, and this is basically how far down you should step down at each step. So this is going to be like a stair-stepped cutting operation to cut out most of the material. But if your machine is not really super rigid, you don't want to set this too high because it might cause some issues when you're trying to machine the part. Your machine might skip, or the bit might skip, or you could cause damage to your machine. So I'm just going to set this kind of low for now, and maybe we'll just set it to 0.0625, which is 1/4 of the diameter of my bit. We'll set optimal load here is half the bit size. Gonna select, this is a bit easier. If you select model, you can select a face, a surface that you want to mill. So I'll just do that. The other thing we'll want to do is set the silhouette as the machining boundary, tool containment outside So it doesn't matter if we go out, when the tool is moving, it doesn't matter if we go outside because we're going to be cutting the rest of this out. So that should be okay. The other thing we'll want to select is both ways so that it's just faster. Doesn't really matter. Sometimes you want to do one way if you want to get like a really smooth surface. Sometimes if you like back cut the material, you can get some tear out, but in this case it doesn't matter because we're just going to smooth it out anyway with the ball and end mill. And there we go, it generated. So let's now create another operation, and this will be the final operation on the back. We'll do a parallel pass, and for this one we're going to select a different tool. So I also have this ball and end mill on my number 6 right here. So this is a 1/4 inch, flute length is 1.5 inches, and it's 3 inches long. So I'm going to select this one, and these should all be fine. You can read all my speeds and feeds here, so set them as your own feeds and speeds if you want. And we're going to do the same thing here. So select this surface here as the area that we want to machine. The height should be fine. We'll go to passes, pass direction. You're gonna have to experiment with this. I like to do it horizontally, I guess, with the body instead of vertically. So left and right. If we're looking at the body this way, I like to go back and forth, left and right, instead of up and down. I think it's just a little bit of a better, smoother finish to it. So we're just going to see what this looks like after I say okay, but we definitely want to change our step over here. Half of the bit size is way too much, so I'm going to set this as something like 0.003. Sorry, 0.03, and then we'll just see what it looks like. If the ridges are too high, we can decrease the step over, but it's just going to make this take a lot longer. So you want to find a nice balance between, you know, smoothness or step over size and the time that you want to actually spend machining the part. But we'll just leave it as 0.03 for now. Both ways is fine for milling direction, and we don't want to leave any stock because we don't want to go down to that final dip. And then I'm going to hit OK and see what this generates. Okay, so this looks good, but it's the wrong direction, so we're going to have to turn this 90 degrees. So let's just go back into this toolpath and hit Edit, and then we'll go down to the pass direction and we'll change this to 90 degrees. Then I'm going to go to the Geometry tab, and I want to set my tool containment as center on boundary. I don't want it to go off the side of the edge and try to machine the side of the body. So we're just going to set this as tool center and hit OK. And so this is looking really good. So we can see it goes left and right, all the way across. And we don't try to machine into the body more than we should here. So this is great. Now we can right click and just simulate everything to make sure there's no errors. And so you see at the bottom here, if you get all green, that's good. Green is good, red is bad. You don't want red. If you have red, it means it's probably something colliding when the bit's trying to go too far into the material, or it collides with the fixture or something like that. So you want to make sure that you don't have any of those. If you do, you can go back into your settings here for the operations and try to adjust them so that that doesn't happen. So let's just run this and see what happens. So the first thing is we drill these holes out, and we start with the adaptive clearing. And this takes quite a long time just because we're hogging out so much material. So we'll just let this run for a little bit, and you can speed it up down here if you want. And then we do the parallel operation right here. And everything looks good. So if we look at the time here, it takes an hour, which isn't too bad. So I'll probably just leave this as is, and I'll hit exit simulation. All right, so now we'll do the front. I'm just going to hide this reverse fixture, show the other fixture, and flip it around. And the first thing we are going to do on the front is actually the same thing that we did on the back, which is the adaptive and the parallel cut right here. So I'm just actually going to copy both these and paste them right into this setup. And so I'll have to change the model face that I'm referencing here. So I'm going to go back into my model, and I'm going to select that face, and I'm also going to make sure my fixture is set correctly, which it is, and I'll hit OK. This takes a while to generate. I'm going to go into my other one, do the same thing, edit, and make sure I have the correct face selected. Okay, now this looks great. Next thing I'm going to do is the contour of this guitar. So I'm going to go into my 2D operations and select 2D contour. And then for this tool, I'm going to use that same upcut and mill. So we'll just select that one. And then for the geometry, I'm going to select a contour. So I'm actually just going to open up my sketches and select this outline here of the body that we used to create the model. And then when I go into my heights, I'm going to say that my bottom height is actually the model bottom. So it's going to go all the way to the base. And then I'm going to go back into my geometry and select tabs. Now, whenever you do a cutout of something, you usually want to use tabs because help hold the model in place when you are cutting it out, so it doesn't like fly off the machine. Now, if you had tape securing this, like with the CA glue and the tape trick, then it would stay on the machine, but it's just easier to hold it in with these tool dowel pins and then keep it locked in with these tabs. So we're going to do that. Now I'm going to select the tab width and height. So the height is pretty small here. You can see it's only this small, so usually I like to make it at 1/4 inch by 1/4 inch. So I'm just going to change this to 0.25, and then I'm going to do manual tabs because I don't want to have tabs in locations like this where it's not actually going to be connected to the body. So I'm going to start selecting areas along the side, and first thing too is I need to remove all of these existing tabs. So I'm just going to say 0 as my tab distance. And then I'm just going to start selecting locations that I think would be good for the tabs. So I don't want to be too close to the edge of here of my stock because they won't be connected to anything. So I'll just look at some meaty areas. Maybe I'll put one right here, one right here, and I'll just go around the body and maybe add like 10 tabs. Usually that's good. Now I'm going to go into my passes, and for this, you'll see once we do the machining operation for the neck pocket, we want to have a big enough area where we can insert the tool into that slot that we cut for the contour and then start milling the neck pocket. So I'm actually going to do 3 passes, and this takes quite a long time. It's the longest operation in the entire guitar cut because you don't want to go too deep because you're just milling straight into solid wood for that first cut. You don't want it to be too deep because it could lock up the machine, and we're going to have like a small offset on each pass. So I'm going to set this as 3, and then our step over should be 0.025 is probably okay. You could probably do a little bit higher than this if you wanted, but in this case I'll just do like 0.04, and we definitely want to do multiple depths. And this is what I was talking about for the roughing step down. We don't want to make this too much. So I'm just going to do 0.0625. And we want to uncheck rough final. So rough final is where it does an extra pass at the end to cut out, to basically smooth out everything. But this doesn't really matter because we're going to be sanding the side of this anyway after we cut it out. So I'm going to uncheck that. And then you might also want to leave a little bit of stock because we're going to be sanding it. So I like to do 0.02 inches for radial, but for axial, I like to leave it at 0 because we're not going, we want to go with the full depth of the part here. And everything else should be good, so we're just going to hit OK and see what it comes up with. This looks good, but I think our step over could be a little bit more. You can see these cuts are pretty close together, so I'm actually just going to go back into here, edit it, and then change the step over to 0.1. Next thing we're going to do is cut out these pockets. So we are going to do a 2D pocket operation, and I am just going to select these 3 pockets here. And we'll want to make sure that our tool is the right tool. So we have this 1/4 inch 2 flute upcut, which is what we want. We want to make sure the bottom height is the selected contour bottom height, so it goes all the way down to the depth of the pocket. And then we'll go into our passes here, and I think the step over is a little high, so I'm just going to change this to 0.1, just like we had for the contour. And I am going to unselect stock to leave because we don't want to leave any extra stock in these pickup cavities. And then I'll just hit OK. Oh, and last thing too is I want to make sure we have multiple depths. So in this case, maybe we'll also do 0.1 inch as the depth, and we'll hit OK. Now we're going to cut out the neck pocket, and for the neck pocket I like to use a different operation. I like to use the 2D adaptive because I feel like it gets a better entry cut instead of just starting in the middle and working out. It starts from the edge actually. So I'm just going to do an adaptive clearing, and I'll set the model here, and then we'll make sure we have the correct tool, which is the upcut end mill. That should be fine. Let's go into our passes. This case, we're going to leave some radial stock because we want to make sure it's the full depth, but we don't want to go the full width because we are going to cut a little bit more out with a second operation, which I'll show you in just a second. So let's set the axial as 0. We don't want to go both ways. I feel like it's a better cut if you just go do a climb cut. The optimal load, maybe we'll go 0.1 again for this. And we'll select multiple depths. Maybe we'll also select 0.1 for this and hit OK. So you'll see it starts at this corner and it has multiple depths here. So we do leave a little bit of material here on the side. I don't know if you can see that, but there's a little material left here. And the reason I like to do another operation here is because it'll just clean up that edge really nice. So when we go to put the neck in, you'll get a perfect fit. So to do that, I'm going to do another contour operation. So we'll go into 2D contour, and then for this we'll keep that upcut end mill. This should be fine. And then we'll go into geometry, and I want to select this contour right here. And we'll just select the full contour, and we want to make sure that these arrows are inside of the line here because we want to cut the inside out. We don't want to cut the outside or we'll take a big gouge out of our part. I'm going to go into my passes. We'll do multiple depths again. In this case, we're going to do a large depth though. Maybe we'll do 0.25, so the full width of the bit. We don't need to do rough final here. And then maybe in this case we'll leave just a tiny bit of stock. And the reason why I like to leave just a tiny bit is so that when we fit the neck to the pocket, the neck will be a little bit oversized, so we can sand the neck down and get a perfect fit. So 0.004 should be fine, or maybe 0.003 even. Everything else should be okay, and then we're just going to hit OK. We have 2 more operations. One, we need to bore these holes out for the neck bolts. So I'm going to go back into the 2D bore. I'm going to select all of these holes as holes that I want to bore out. And then for my tool, I'm going to use a different tool. And so if I go into my tool library, I have one that is a long end mill here. So it's a 3-inch 1/8 flat end mill. So it's long enough to reach through the body. My flute length is 1.5 inches, so this should be fine. And then I'll just hit select. And then all the defaults should be fine. You can look at my feeds and speeds here. And then I'm just going to hit OK. Final operation will just be cutting these points out for the bridge. So I'm going to go into my 2D operations. Sorry, I'm going to go into drilling, and I'll do a drill operation. We'll select all these holes, and then I already have a bit configured for, if we go to my library, I have this 1/8 inch drill bit. This is just a normal drill bit. You can also use Endmill if you want, but this should be fine, and then we'll just select it. We're going to do a different cycle type, so if I go into my cycle, this will just do a single drill down and pull out, but in this case you probably want to do some chip breaking, so it'll partially retract each time it goes down. So we'll select that, and the defaults are fine here, so we'll just hit OK. So if we just right click on this and simulate, we can make sure that there are no errors, which there aren't. Machining time is about 3 hours, which is a little high, so you could increase the speed on some of this, or maybe even the depths of these different cuts if you'd like. But for me, this is fine. And if we play this, we can see how it runs. Everything's looking good, so I'm just gonna speed this up, have it go all the way through. Looks great. Okay, so we'll exit the simulation. Then you want to post-process these. So if you right-click on the setup and you go into post-process, you can post to the correct file type. So we have Gerbil for my Carbide 3D machine. You have to select the correct machine code type for your machine. Then you can name it whatever you want and output it to a specific folder. So I'll do one for the back. I'll do the back first, and then I'll do one for the front. And they'll load it up on my machine. So here's what the guitar looks like when it's finished. As you can see, we have it held in place with those tabs, and there's some fuzzies on top. That's okay, we can clean those up with some sanding. We'll just run over it with some 220 sand grit, and then it should get rid of those fuzzies. It's just from the upcut bit. Next, we have to get it out of this stock here, so we'll have to cut those tabs. And I like to use a Japanese handsaw just because it sounds cool, but you can use whatever you want. I've also seen people use hacksaw blades because they're much smaller. Usually I use the handsaw for the easy to reach tabs, and then I'll use a tiny little hacksaw blade to get the ones that are on the horns of the guitar. Then I'm going to take the guitar to my router table. I'm using this flush trim bit, and it has bearings on the top and bottom, and it's also a compression bit, so it gets a really nice clean edge. Depending on what you use for this, you can get some tear out, so you want to just make sure you take it slow here. Next step will be cleaning up that neck pocket. So like I mentioned, we leave a little bit of material here, and so you'll get a little bit of remaining material on the side of the neck pocket. Obviously you don't want that on your guitar because it just doesn't look very good. So I'll use a little clippers to clip off that extra material, and then I'll clean it up with a chisel. So the clippers just get the majority of it, and then the chisel gets a nice clean edge. Here I'm bringing in my spindle sander. And I use the spindle sander to clean up any remaining little marks from the router table on the sides of the guitar. It just gets a nice clean edge. So usually I don't even bother with anything lower than 220 here. I like to use 220 and just, go a couple passes on the guitar, cleans it up really nice. You want to just make sure any remnants of those tabs are gone. Then I'll bring it back to the router table one more time, and here I'm putting a nice little round over on the edge. Just depends on what type of guitar that you're building, but for teles it's usually like an 1/8 inch or 3/16 inch, and then for these type of guitars I usually like to use like a 5/16. Here's what it comes out looking like. I think it looks really great in my opinion. Just removes any safety concerns that you might have if you're trying to do it with a router. And it's a repeatable process that's really easy to do when you have all your CNC files set up. Obviously we'll have to do some more cleanup work here to do some more sanding on the edges and round out that arm contour. But The thing's looking great, and I'm going to make this into a 5-string bass for my wife, so stay tuned for that. I'll catch you in the next one.